Okay, so to continue forward with this, so particles in solid, we're kind of repetitive, we've already talked about this. So particles in solids are tightly packed together, and in general, they have very little energy, right? So they're moving, but they're still moving slowly. Particles in liquids are loosely packed, so there's more space between them in comparison to a solid, and they have medium levels of energy. So these are just very generic. It's almost like we're just ranking them. Like liquids have more energy than solids do, right? And then gases have more energy than liquids do. And gas particles, there's more space between them, so they're moving more freely. Now, particles in a plasma have extra energy that is added. So of course they have lots of energy. So you have to imagine they have the same amount of energy as gases plus the additional energy that was added to them. So they have quite a bit of energy, actually to the point where they're relatively unstable, right? As soon as that extra energy is removed, they go back to behaving like a gas would. So let's look at different states of energy, different states of matter. So we've looked at the different states, right? Solid, liquid, gas, plasma. Now, how you go between the different states is you have to either add in or take away energy, right? So to go from a solid to a liquid, you have to add energy. From a liquid to a gas, you add energy. From a gas to a plasma, energy is added. Now, normally, to go between solid, liquid, and gases, we always refer to energy in the form of heat, right? So think about if you have liquid water and you want to make it into a gas, you would boil it. Let's say you boil water on the stove. So you would add in heat energy. Now, typically when we're talking about the energy to become a plasma, we're referencing electricity mostly. Okay, so that doesn't mean that you can't use other forms of energy, but the most common way, right, if you were looking at melting an ice cube, you would be using heat to do that. Okay, so to go from a solid, I should mention also, if we had to, let me erase this. If we had to do the reverse, so let's say we wanted to go from, right? We wanted to go from a gas to a liquid, you would have to remove energy, right? To go from a liquid to a solid, you would remove energy. And of course, we know going from a plasma to a gas, you would take away the electricity that's been added in, right? So usually when we're doing this, you would add heat. So if we go down this way, you would be removing heat. Okay, so another way of thinking about removing heat is to cool it down, right? So if we wanted to make ice cubes from liquid water, right, what do? We put it in the freezer. We cool down that water. Okay, now the point in time that we're referring to here between them is actually part of what's called a physical property of matter. So in the time between solid and liquid, right, so this transition period, this is called the melting point. Okay, or sometimes you can see this being called the freezing point, depending on if we're adding heat or removing heat. So the time that the temperature that it takes to go from a solid to a liquid or a liquid to a solid is known as the melting point or freezing point. Okay, but melting point is used most often. So this temperature essentially will indicate what type of state of matter you have. So for example, for water, this is 0 degrees Celsius. So that means if we are below 0 degrees Celsius, we have a solid. And if we're higher than 0 degrees Celsius, we have a liquid, right? So the 0 degrees Celsius, exactly at that temperature, you have a transition state. So water is in between states. It's either, depends on if you're adding heat, it's going from solid to liquid. If you're removing heat, it's going from liquid to solid. Now, let's say we were dealing with liquid to gas. This is another transition time. So this is known as the boiling point or sometimes it's referred to as the condensation point. But to be honest, the most common form is the boiling point. Now, the same thing, the temperature is the transition. So for water, this is 100 degrees Celsius. So meaning if it is lower than 100 degrees Celsius, we have a liquid. If it's higher than 100 degrees Celsius, that means we have a gas. And at 100 degrees Celsius, we have a transition time. So let's review that. So for water, 0 degrees is transition between solid and liquid. And then 100 degrees is the transition between liquid and gas. So what that means is if you're given a temperature, you should be able to predict what the state of matter is. So for example, at 25 degrees Celsius, water is in between the 0 and 100 mark, which means that this is going to be a liquid. If we had negative 10 degrees Celsius, we're below the 100 mark, so this would be a solid. If we were at 75 degrees Celsius, what would we be? We would be a liquid because we're still between the 0 and 100. If we were at 105 degrees Celsius, we would be a gas because we're higher than the boiling point. So knowing the boiling point of, the boiling and melting point of different states of matter, like different substances, it gives us a lot of information, and every substance has its own unique values. Okay, so I'll give you an example. Let's use something different. Let's use aluminum. Okay, so let me look up aluminum. Aluminum melting point. Okay, aluminum's melting point is 660 degrees Celsius, roughly. Okay, let's look up the boiling point. So the boiling point of aluminum is 2,470 degrees Celsius. So it's very different from water. Remember, water was 0 and 100. But the values are still the same. If we were below the melting point, that means that we have a solid. If we're higher than the boiling point, that means we're dealing with a gas. And in between the two, we have a liquid. So this can be done with any type of matter, right? All matter has its own unique melting and boiling points. So I'm going to give you some numbers here, and I want you to practice writing what the state of matter would be for that. All right, so this should be a quick one. Maybe pause the video for a second and write if it would be a solid, liquid, or gas at these temperatures. Okay, so here we have in between the melting and boiling point, so this should be a liquid. Here, this will also be a liquid. We're still not above that boiling point threshold. Here we have a solid because it's lower than the melting point, and the last one would be a gas because it is higher than the boiling point. So melting and boiling points are called physical properties. So these are aluminum's physical properties. And then of course water has its own unique numbers. Every type of matter has its own unique values. All right, so taking a look at this, now this is going to seem a little bit simple here, but we were already looking at this. So when we're going to from a solid to a liquid, remember you would add energy in to do that. So an example of this would be, let's say we wanted to melt an ice cube, right? Or I don't know why I can't think of anything else. Going from a solid to a liquid, or a snowflake melts. Right? Something along those lines. Something that's going from a solid to a liquid. Maybe a popsicle is melting or something, right? Something that's solid that is becoming a liquid. To go from a liquid to a gas, again, you add in energy. So this could be like boiling water or evaporation, right, from the water cycle. So evaporation or transpiration, right? We're looking at the process of going from a liquid to gaseous water. Now, it's important to keep in mind, it's still the same substance. So when we're going from liquid water to gas water, it's still water. You're not changing the particles that make them up. All right, so changing states, when we talk about going from one state to another, it has a bunch of different terminology. So we can say that so let's say we're going from a gas to a liquid, right? So this change in state would be known as condensation. Like that's the process that's happening here. So we can call that a change in state, a change in phase. Okay, so if you ever see the term phase, that's basically another way of saying state. Or we can say this is a physical change. So basically, we're changing how that particle appears physically. So it's going from a gas to a liquid, but it's still the same particle. It's just the physical appearance of it might be changing. So any of this terminology means exactly the same thing. It just means that we're going from one state of matter into another state of matter. So this last slide here is just talking about, pardon me, sorry, got interrupted for a second. So this is just looking at different states of matter. So I want to just be clear. So we're looking from solid to liquid to gas. So they're using water as the example. But remember, any type of matter can go from solid to liquid to gas, right? We looked at aluminum, for example. So solid to liquid is, so look at the arrow direction. Also, the blue arrows means that we are adding in energy. So in this case, they're using heat in the form of heat, like I mentioned. And all of the red arrows are representing the removal of energy. Or think of this as cooling. So this is like heating up. And this is cooling down. Okay, but the proper terminology here is addition of heat or addition of energy, removal of energy or removal of heat. So let's follow along with the blue arrows. So to go from a solid to a liquid, that's known as melting. From a liquid to a gas, that's known as evaporation. Now, there are some types of matter that don't have a liquid state. It actually goes straight from solid to gas. So that's known as sublimation. There's not too many things that do that, but carbon dioxide is one of them. So carbon dioxide can have a solid state and it goes directly into a gas state. And actually, when it's in its solid state, it's called dry ice, if you've ever seen dry ice before. So the reason why dry ice is safe to use, let's say if you're at a wedding and it's on the dance floor, it's because it doesn't become a liquid. It just sublimes into the air. So what that means is the people who are dancing on the dance floor won't slip or fall because it's not a liquid. It's not like ice when it's melting, when it's water, right? So that's called sublimation. So when you have removal of energy, let's follow the red arrows. We have condensation when we're going from a gas to a liquid. We have freezing when it's going from a liquid to a solid. And sublimation also goes in the reverse way. And actually, this is also known as deposition. So you might have learned it with this. But technically, the terminology of sublimation can be used for both going from gas to solid or solid to gas. But this is correct as well. Okay, so that is essentially matter and states of matter.